Hello everyone, now we will see what is linear circuit and a non-linear circuit. Okay. So, before going to see exact definition of the linear circuit and non-linear circuit, we should know what is linear element and what is non-linear element. Okay. So, for example, in our previous class itself I have told that RLC are linear elements. Are linear elements. Why? These are following the linear characteristics like y is equal to mx. If you change the input output quantity, that means its effect will also be changed in proportional to the input only. If you increase the input, output will be increased or effect will be increased. If you decrease the input, then effect will be decreased. So, in case of the resistor, we can able to tell V is equal to R into I. If you keep on increasing the voltage, current will be increased. If you keep on decreasing the voltage, current will be decreased. In case of the inductor, you can take magnetic flux is proportional to I, that means current flowing through the inductor. So, if you remove that proportional, you will get the proportionality constant inductance L. So, here if you increase the current, magnetic flux will be increased, decreased the current means magnetic flux will be decreased. So, again you will get the linear relationship between magnetic flux psi m and current I. And as I said in the previous lecture also, the capacitor relation is given by Q is equal to CV. So, Q is proportional to V, that is why capacitor is also linear element. So, these three are linear elements. Okay. Then what is linear circuit? The circuit which is comprising of all the linear elements, then we can tell that particular circuit is the linear circuit. Whatever the elements are there, for example 100 elements are there in the circuit, all those 100 elements must be linear elements only. Okay, you may have the combination of RLC, you may have only resistors, you may have the combination of resistor and inductor, like that any combination you can take using these three components, for example, then that particular circuit is said to be linear circuit only. Okay. And all the elements must be linear, that is the key point here. Okay. All elements must be linear elements. All elements must be linear elements. Now, what are the non-linear elements we have? Diode is non-linear element. So, diode is a non-linear element. How to tell that one? This is the diode symbol I have taken, circuit symbol. If you apply voltage across the diode, if you apply certain amount of voltage across the diode, then what will happen you see. V voltage we have provided, then I current is passing through the current. Okay, I current is passing through the diode. Then what will happen we will see. The relation between this voltage and current is given by diode current equation generally, that is I is equal to I naught into e power V by eta Vt minus 1. So, using this equation itself we can tell diode is a non-linear element, because if one element or one system is linear, then it has to follow the superposition principle. But if you observe here, the voltage and current relationship is exponential relationship, it is not linear. Okay. Linear means a straight line passing through the origin, but here what is happening? The relation between voltage and current is given by exponential relation here. Okay. So, if you apply the voltage, the current is increased exponentially, that is what we can tell from this mathematical equation. Here eta recombination factor, that is constant, thermal voltage Vt constant, and reverse saturation current I naught, and 1 anyway constant. All these things are constants. So, the effect I is based on the voltage V exponentially. So, exponentially means if you see the forward bias characteristics of the diode, we will see like this. Okay. So, it is not a straight line passing through the origin, so that we can give the conclusion that diode is non-linear element. So, In one circuit, if you have one diode or more than one diode, then we can tell that is a non-linear circuit. But in addition to this diode, you may have resistor. Resistor is linear, but diode is non-linear. So, how to call that particular circuit is nothing but non-linear only. Okay. So, at this moment I am taking the definition of the linear circuit again. Linear circuit means all the elements available in that particular circuit must be linear. Non-linear circuit is nothing but at least one element, if it is a non-linear, then that circuit is said to be non-linear circuit only. Okay. So, non-linear circuit is nothing but at least one element, is non-linear, then the circuit is said to be non-linear circuit. Remaining elements can be linear also. Okay, but at least one non-linear element is there like diode, then we can conclude that that particular circuit is a non-linear circuit. So, these are the definitions of the linear circuit and non-linear circuit. In our first module, we are going to see about the linear wave shaping. So, we are going to work with linear circuits only. But in the second module, we are going to see non-linear wave shaping. At that moment, we are going to use the non-linear circuits. Okay. Now, anyhow, to understand the basics, I am telling regarding this Kirchhoff's laws also, those are KVL and KCL. Okay. We are going to use KVL several times, that is why just I am revising that one. So, KVL is a Kirchhoff's voltage law. Basically, KVL is applied in a loop and KCL is applied at a node. So, in a loop at any time, okay, the algebraic sum of all voltage drops is equal to 0. Algebraic sum is nothing but you have to consider positive and negative also. Okay. Similarly, KCL is nothing but at any node at any time, the algebraic sum of all the leaving currents is equal to 0. I did not say entering is equal to leaving, that entering itself is minus of leaving. So, that is why we are telling the definition like algebraic sum of. Okay. So, anyhow, I am interested to talk about the KVL compared to KCL, because several times we are going to apply the KVL. So, Kirchhoff's voltage law, once again I am repeating that one, in any loop at any time is very, very important. At any time, algebraic sum of all voltage drops, is equal to 0. Okay. So, that is what you have to remember. Okay. And in order to have some interest on the subject, I am giving what is required in our subject, what is to be remembered like in numbers, those numbers I have given here. Okay. So, what is the E value? We know about that one, that is 2.71. You required to know about e power minus 1. Okay, not only in our subject, in some other subjects also it is required to know about e power minus 1. If you calculate this one, you will get 0.367. And it is required to know about 1 minus e power minus 1 also. So, if you calculate this one, you will get 0.632. Okay. So, we are going to work with 36.7 percentage of some value, and we are going to work with 63.2 percentage of some value. That is why just to have the interest about this one, I am giving these numbers, you try to remember these values. Okay. So, next, exponentially increasing nature is required for us and decreasing nature is required for us. Okay. So, we know about mathematical expression for the exponentially decreasing signal or exponentially increasing signal. Okay. So, for example, e power minus t I have given. If you want to draw this particular signal e power minus t with respect to time only on right side means we have to multiply with u of t signal, that about that one already we know. So, by default we will see on right side only here. So, always no need to mention u of t, by default we are working on right side. Okay. So, x axis is t. If you take t is equal to 0, what is the value of e power minus t? E power 0, that is 1. If you take t is equal to 1, e power minus 1 value already I know, that is 0.367. Okay. So, at t is equal to 1, the value is given by 0.367. Like that, if you keep on increasing the time value, the e power minus t value is decreasing. Okay, it is decreasing. At t is equal to infinity, e power minus infinity will become 0. So, e power minus t means we are getting the graph like this, exponentially decreasing graph. And if you take e power plus t, okay, and if you draw this particular signal with respect to time, then the value is increasing. But instead of giving this particular e power plus t for the exponentially increasing case, if you take this one 1 minus e power minus t, this is also exponentially increasing only. We are subtracting e power minus t from 1. Okay, then what will happen, you see, 1 is the constant signal minus e power minus t, just now we have seen it is like this. Okay. So, at t is equal to 0, the 1 value is always 1 only. So, here 1 is there, and at t is equal to 0, this e power minus t is having the value is 1. So, if you subtract these two, you will get 0, 1 minus 1 is 0. At t is equal to infinity, what is the value of the signal 1? 1 minus at t is equal to infinity, the value of the e power minus t is 0. So, if you subtract the amplitudes 1 minus 0, you will get 1. At t is equal to infinity means I am taking here. Okay. And in between, if you draw, you will get exponentially increasing signal means like this you will get. Okay. So, what is required to know here? Before starting our subject itself, I am giving some what is important, what is required for us to understand the subject, just a little bit I am giving. So, e power minus t means you have to remember this particular structure, exponentially decreasing structure, and e power 1 minus e power minus t is nothing but it will be increased, exponentially increasing up to 1 only. Okay. If I give e power t, it starts from 1. Okay. T is equal to 0 means it is starting from 1 and exponentially it is increasing like this. But in my subject, in our PDC subject, we are going to deal with this type of structure. Okay. So, maximum value is 1 only for this particular thing. So, it is exponentially increased from 0 up to 1. So, there is a change in between these two exponentially increasing signals. Okay. 1 minus e power minus t, what is the nature of the signal you have to understand. Okay. And e power t, what is the nature of that particular signal. We are going to work with this one and this one. Okay. Then we will see remaining things in the next class. Thank you.